Okay, that said, ladies and gentlemen, notebooks, take him on out right now. All right, so ladies and gentlemen, today we're dealing with special cases. Okay, we're going to be doing the same thing that we did last week, where we were working on substitution method. So we were using systems of equations and making use of, or working with systems of equations and making use of the substitution method. Well, that's what we're doing today. So let's take a look at that. Alright, so let's take a look at this. We have our learning target. Basically, for today, what we're going to be working on is working on special cases with the substitution method. Okay? Now, for systems of equations. Okay, so we're working on special cases with the substitution method for systems of equations. Okay, and there's actually a few special cases. First, the fun one, constant term. So some of you, I gave you guys some of these as practice problems last week, but substitution method, using just a constant term, that's always fun. Then we have no solution and infinite solutions. Okay, no solution, again, just to kind of reiterate, we did talk about them, but we didn't have specific problems last week. So no solution is when two lines are parallel. Well, if two lines are parallel, they will actually never touch each other, therefore they can't have any solutions. Infinite solutions, last one. Infinite solutions is when the one line is on top of another line. If two lines are on top of each other, then they'll be touching each other forever. Okay? So, these are what we're going to be working on today. We're going to deal with the constant term, no solution, and infinite solutions. Let's try that out. Example 1. So let's kind of zoom in on this. Whoa. Alright, so example 1. This is the constant case. So this is constant case. Example 1. Now, if we have a constant, that implies y is actually equal to one specific number. In this particular case, y is equal to 8. Well, we do the same as we always do. This one's, again, it is a little bit easier. So, what we want is to rewrite the previous equation. So let's scooch over here just a smidgen and rewrite the equation. So what we have is 8x minus 7 is equal to 24. Now I left the y blank due to the fact, let's just zoom out just a little bit. Oh, it's a little too much. Here we go. So I left the y blank due to the fact that we're actually going to be taking our y value that's over here and just plugging it into this guy. Okay, so what that y was it's going to be placed over here. So this is negative 8. Make that negative sign a little clearer. Okay, let's run through it. First, the 8x is still the same, so we have 8x. Got to distribute in. Negative times a negative is a positive. And 7 times 8 is 56. Okay. We have 8x plus 56 is equal to 24. We're going to subtract 56 from both sides. Over on the left-hand side, they cancel. Therefore, we're just left with our 8x. 24 minus 56 is negative 32. Okay, last part. Got to get x by itself. Divide by 8. Divide by 8. 8's cancel, so x is equal to negative 4. Okay. So notice what we had to do here. First, we had to plug in whatever y was equal to. Well, we found that y was equal to negative 8. So we plug in negative 8 where y once was. Once we plugged it in, we distribute. Negative times a negative is positive. 7 times 8 is 56. And then we just solve. Subtract 56, subtract 56. 24 minus 56, 32. These 56 cancel out, leaving us just with our 8x on the left-hand side. 8x is equal to negative 32. Divide both sides by 8. Lo and behold, x is equal to 4. What's nice about the constant term is we don't have to take this value and then plug it back into another equation, because x is negative 4, y we already knew was negative 8. So with that said, we already can see our solution. Solution. X, y, which is going to be negative 4, negative 8. Okay. So that's when we have a constant term. Next one. Let's take a moment, write it down. We have y is equal to 2x plus 1. So this 2x plus 1 is what we're going to be substituting. So 2x plus 1 is what's going to be substituted into our expression of y. So this guy's going to be dropped into y right there. But like always, rewrite the equation. Okay? Do as much as you can. The more work you do, the more you understand the work and the equation. Okay, so we're going to rewrite this guy. We have 6x minus 3 something something is equal to 7. Okay, 6x minus 3 is equal to 7. Well, our something something is the 2x plus 1. So let's plug that in. 2x plus 1. And if you want, it's perfectly right to use a different color. In fact, that's what I'll do for what I plug in. 2x plus 1. Okay, same as before now. We plugged it in. Now we got to distribute. Bajoom! Bajoom! Again, you don't need to make those bajoomy noises, but it does make the time go by just a little bit faster. Bring down your 6x. Negative times a positive, negative. 3 times 2 is 6, and that's 3 times negative. 3 times 2x, so that's going to be negative 6x. Negative times a positive is negative. 3 times 1 is 3. And then we have 7, standing all by its lonesome. Okay. Combining like terms. Notice what's going to happen here. Once we combine these like terms, 6x minus 6x, well, that's gone. So we're left with 3, negative 3 is equal to positive 7. We have to ask ourselves, is that correct? Does that make sense? Does negative 3 equal positive 7 the last time you checked? No. Okay, that is not true. No. Not true. And so, in this case, we're actually dealing with a special scenario. These are parallel lines. So, parallel lines. So that means we have something like this, and if we have parallel lines, well, these two guys will never intersect. A solution is where they intersect. Two lines don't intersect, then there is no solution. And that is done. That is that. Okay. This is the no solution type. It's nice, you know. Does that make sense? Negative 3 equals 7? No. No solution. Alright. Last problem. Last example. These were just like special cases. We'll have practice over the week. Example 3. Let's kind of zoom in. We got, actually, this is fine. We have y is equal to negative 3x plus 11. And the bottom equation is 9x plus 3y equals 33. Take the top equation, plug it into the bottom. Rewrite the bottom. And just for fun, just for posterity, we're going to be plugging in this guy right there. Back out just a little bit. So I want to rewrite this problem. I have 9x plus 3 something something is equal to 33. Okay. Take this value, the negative 3x plus 11, plug that on in. In fact, let's just switch up the pens here. So we have negative 3x plus 11. After we plug in, we distribute. Ba-choom, ba-choom. Notice that the 9x just comes on down. We've done nothing to that yet. Positive 3 times negative 3x is negative 9x. Positive 3 times positive 11 is positive 33, which is equal to 33. Notice that we have positive 9x, negative 9x. Those cancel, leaving us just with 33. Let's see what 33. Let's see, does that sound right? Yeah, 33 is equal to 33. But that's all we can do. There's no more work. We can't plug values in. Like I don't now have an x value which I could plug into the top equation. So this is the case of infinite solutions. So infinite solutions. And again, infinite, you could put a infinity sign. I'll go back up in just a second. no solution. There's actually a special symbol for that. It looks like a 0. I know many mathematicians, if I say 0, they'll be very angry with me, but it's okay. It looks like a 0 with a line through it. So I believe, I want to say Icelandic or even maybe Danish. Some type of language has that as one of their letters. But this is known as, in mathematics, as the empty set. Meaning nothing is in here. Empty set. Well, how many solutions? Well, it's representing the amount of solutions. How many solutions are there? There's no solutions whatsoever. So there's nothing within this set. And that, my friends, is that. Please look over the video and see you next week.